So 11.1.2, we talked about yesterday or in 11.1.1, what adding a constant to the equation can look like. And today we're going to be talking about inverse functions. Inverse functions, so is nothing more than switching the x and y and solving for the new y. So have you ever noticed that it can be easy to do some things forwards, like reciting your ABCs or the Pledge of Allegiance, but a little bit more difficult to do the same thing backwards? Today we're going to be doing the inverse of functions, which is the same as doing the functions backwards. So that's what it is we're going to do the functions backwards. And we've already kind of done some of these early on in the year by having an output and trying to backfill what the function would be that would give us that. But anyway, if the original function is f of x, which is the same thing as y, is equal to, let's say, 3x, and therefore y would then be equal to 3x, all we're doing is we're taking this and we're going to work it backwards. And so the way that you do that is you just take your x's and y's and switch them. So we would have x is equal to 3y, and then you solve for y, which therefore then x over 3 is what equals y. This is the inverse function of this. So if the original function is f of x, this then becomes what's known as the inverse function of x. And so that's kind of what we're talking about today. So we have a function machine. So here's a function machine, and when 3 is put into a machine, 13 comes out. When 4 is put in, 16 comes out. And this is actually supposed to be a -3. So when -3 is put in, -5 comes out. So when we put in 3, we get 13. When we put in 4, when x is 4, we get 16. And when we put in -3, we get -5. So the thing we got to figure out is, what is this f of x? What is the actual f of x actually equal to? What is the math that's in that does this each time? Because this function machine is doing the same f of x to every number that gets put in. It doesn't matter. So if we put in 4, if 4 goes in, we get 16. And if -3 goes in, we get -5. And we already see that if we put in 3, we get 13. So what is this f of x machine doing? And we can kind of figure that out if we look at what our first input is. If our first input is 3, we do some math that gets us really close to 13. And so I'm going to say, okay, let's see what we can do that gets us close to 13. Some things we can do is multiplication. So I'm going to do some multiplication first. I'm going to go times 4 first, just as a guess. Times 4. And that's going to give me 12. And we go plus 1 will give us 13. So now if we go 4 times 4 is 16, that's not going to work. So we know it's not times 4. So let's try something else. Let's try times 3. And that gives us 9. And that's pretty close to 13. It's not over. So 9, we can then add 4 to that, and that will give us 13. So that works. So then we're just going to try and copy all of this mathematically for the next input and to double check it. So if our next input is 4, and we then go times 3, that gives us 12, plus 4, that's 16. So that checks out. So apparently this is the math that's happening. So now we try it with our final input of -3. And -3 times 3 rather, negative 3 times 3 gives us negative 9. And negative 9, then we add 4. We're doing the same thing at each spot. So negative 9 plus 4, that's definitely negative 5, so that checks out. So we can say without a shadow of a doubt that what f of x is actually doing, f of x, in this case, the function, is equal to whatever x is, we multiply it times 3, and then we add 4, and we keep the order of operations in play. And the way that that would be written, if you were to see it on another piece of paper, is f of x is equal to 3x plus 4. Another way you could see that is y is equal to 3x plus 4. Because f of x is another way of writing down y. So that's our function. And that's a circle. And this is what I wanted. So that's what f of x is. F of x is 3x plus 4. So in looking at this then, what if we did it backwards? And we did the inverse function of this to get the same number. So we're inverting f of x. So we put in 13. So the inverse of this, so if we were to work this function machine backwards, the inverse function of f of x, if that's going to be 13, so if we actually put 13 in, and this is working backwards then, it's almost like putting the number in here and it shoots out the top. What's the backwards math that happens? That's what this means. So we have f of inverse of 13. That's going to give us what we should have gotten in the first place, which is very simply 3. So the f inverse of 13 will give us 3. And then that means that the f inverse function, backwards function, of 16 should give us 4. And then the f inverse, working backwards, of negative 5 should then be negative 3. And that's working it backwards. So it undoes the output, recreates the original input. So if we put 13 into this backwards machine, we get out 3. This just means it's working backwards. So this is just working backwards. It's working backwards. So we would take the steps we would get and we just work them backwards. And we'll be getting to that in a little bit. That's the understanding of what the inverse function does, is it works it backwards. So we're doing backwards math today. So now we have to write down the inverse function machine that does it backwards. So originally, when we had f of x, we had 3 times x plus 4. That's the original one. That's what we got right here. F of x is 3x plus 4. That's our original function machine. But working it backwards, we have to do everything backwards in the reverse order of operations. So f inverse of x does the reverse order. Reverse order in order. And what I mean by that is, since we added 4 last, we would take away 4 first. And then we would, since we multiplied by 3 first, we would divide by 3 backwards. Reverse in order and undoing. And so we undo it all. So we not only do the reverse order in order, but we also have to undo everything. So that means that it's this thing backwards. So f inverse of x if we put in 13, so remember this is our original function. So first thing that we did, so the first steps for this, let's just write down our steps first, is we multiplied times 3, and the second thing that we did was we added 4. So down here, the first thing that we have to do is subtract 4, and the second thing that we need to do is divide by 3, because we are undoing all of this. So that's what this means right here. So this is how we're going to have to work this out. So reverse order, and here's our original order, comes to here, reverse order, undo it all, do it all backwards. So the last thing, the opposite becomes the first, etc. So what we would end up with, the F inverse of this, inverse of x, is going to be, first thing we have to do is we got to take x and subtract 4. We're going to take x and we're going to subtract 4, and then to all of that, we then divide by 3. And so there's another way of writing that, which you could also write it as the F inverse of x is equal to x minus 4, and then we divide by 3. And so let's see if that actually works. So if x is 13, if we put 13 in here, so the F inverse of 13 is going to be 13 minus 4, which is 9, and 9 divided by 3 is 3. So let's just work that out and see if that works. So that becomes 13 minus 4, then divide by 3. And 13 minus 4 is 9, and 9 divided by 3 is 3. So the F inverse of 13 is 3, and that checks out, because the original f of x, so we have f of x, our original equation, was 3x plus 4. Therefore, then the F inverse of that is x minus 4, and all of that divided by 3. So that's how these things relate. This is our original, and this is our inverse. And that's all that is. So it's backwards. And the big question is then, how do you get this? How do you know that this is this without going through everything and trying to figure it out? And you just use everything that you've known. So this is what we have here. So our original equation, this is our original function g of x. So g of x, if these are the steps, we put in x, we multiply by 5. So first we take our x and we multiply by 5. Then we subtract 8, and then we divide the whole thing by 2. In order. So another way of writing g of x is very simply 5x minus 8 over 2. These two things are the same. So we first take 5. So if 3, what was the output if 3 is put in? So if we take, so we want to figure out what is g. So this is our equation for this right here. So our equation is g of x is equal to 5x minus 8, and all of that is divided by 2. Because each time you go through a step, it's going to give you a value, and you have to keep that value consistent. So we put in x, multiply by 5, subtract 8, then whatever number we get, we divide by 2. It's just like doing, this is a calculator. It's a calculator, but after every thing you put in, you hit equals. So we put in x. So x is 3 equals 3. Times 5, 15. Minus 8, 7 equals. Then divide whatever you get by 2. So each time you're hitting equals with an answer, and that will help keep you steady with the mathematics you got to do. So if we take g of x, is 3 is put in. We then go 5 times 3 minus 8, and all of that divided by 2, which is very simply 15 minus 8 divided by 2, which is very simply 7 divided by 2, which is 7 halves. And 7 divided by 2 is 3.5. So we could simply say that g of 3 15 minus 8 is 7, and then you divide everything by 2 is 3.5. So if we put in 3, this is our output here. We get out 5, 3.5. So that's what we get. So Kimberly was then asked for the steps of the inverse machine for this equation. So if you remember, the first thing that we did was we put in x. X goes in. The second thing we did was we multiplied by 5. The third thing we did was we subtracted 8. And the fourth thing that we did was we divided by 2. Now we're going to do the inverse of that, which reverses all this order. So the inverse then takes this, and the fourth step becomes the first, so we do everything backwards. So now the fourth step is first. So first we're going to take it and we're going to multiply by 2. We do the opposite in the opposite order. And then we're going to add 8, and then we're going to divide by 5, and then that's going to give us x. So that's what we do. So this is the order that we go in. We go, instead of going for this is f of x. This is the f of x order, and this is the f inverse of x order. So first we're going to do, so the inverse of this, let's see if we can make sense of this so we can get the job. Actually, they're calling it g of x, whatever. So g of x, g of x, the original g of x was here, 5x minus 8 over 2. So g inverse of x is going to take the blue order. So g inverse of x is going to take this order. First thing we're going to do is we're going to put in the x. We're going to multiply by 2. Then we're going to add 8. And then we're going to divide by 5. So if you look at these two, it kind of looks similar. We have 5x minus 8, but here we have 2x plus 8 because we did this order. So that's what we would get for g of x. And there's a pretty, it seems complicated. It's more so less complicated than it is a little bit confusing because you just have to work backwards and it takes a little bit of practice. But what we're doing in between these is we are reversing the steps, and you do the opposite or you undo the operations. And that's what's happening between g of x and g prime of x. So there is another way to kind of figure this out. So there is a bit of another way to figure all this out. And it's kind of what I talked about early on, is you just simply take it and you switch your x's and y's because you want to do it backwards, and you solve for y. And I'll show you what I mean by that. So we already know this is it. So if we know that g of x, this is g of x right here. So if we know that g of x is this equation here, 5x minus 8 over 2. We know that g of x, another word for that is y. So we can always say that that's going to be y. So here's what you do. Is you take your y, you put it in for x, and you write it backwards. So we're going to rewrite this as x is equal to 5 times y minus 8 over 2. And then we're going to solve for y to get y by itself. So I'm going to rewrite this. So we have 5y minus 8 over 2 is equal to x. And what we then do is we start undoing this, and we have to get the y by itself. And so the first thing we do is multiply by 2, because that gets rid of the dividing by 2. And that gives us our 2x, which is good because that's what we have right here. And then we're going to add 8. So we're going to get 5y is equal to 2x plus 8. And then, which is good because that's what we have, 2x plus 8. And since this is 5y, we divide by that to divide by the 5 to get rid of it. And so it divides out, and then we have 2x plus 8, all of that over 5. And so that is the inverse of x, is 2x plus 8 over 5. And that is the exact same thing that we have before. These two things are the same. So you can go through the steps, write it down, then reverse and undo it and get it, or you can switch your x's and y's and solve for y if you're a good equation problem solver. But there are two ways to figure this out now. So we switched x's and y's. We switched our x's for y's, and then we solved for y. So here we have this equation, and we're going to prove that we are correct by putting in a number. So the inverse of this, so this is going to be y is equal to 4x minus 12. That's our original. Switch our x's and y's, which then gives us x is equal to 4y minus 2. It's a direct swap. And now we solve for y. So first thing we're going to do is add 2. So then we get x plus 2 is equal to 4y. And then we divide by the 4, so it divides out. And we get x plus 2 over 4 is equal to y. And that is our inverse function. So that is our n inverse of x, is this. So if we were to put in, let's just say 1. Let's put in 1 or 2. We'll put in 2. So if x equals 2, so we go 4 times 2, which is 8 minus 12 is negative 4. So this is how we're proving that we're right. Okay, so our original equation here is this. So if we take n of 2, that becomes 4 times 2. I just jacked this whole thing up, didn't I? That's supposed to be a minus 12, which changes things a little bit. Minus 12, plus 12, 12, and that's how it changes it. No big deal. Okay, so we get 4 times 2 minus 12, which is then 8 minus 12, which is negative 4. So n of 2 is equal to negative 4. But if we're going to do an inverse of negative 4, we should end up with 2. So let's just take this, x plus 12 over 4. Let's see if we did it right and that correction works out. We then have negative 4 plus 12 divided by 4. And negative 4 plus 12 is 8, and 8 divided, so we then get 8 divided by 4. And lo and behold, the n inverse, when we put in negative 4 into it, is we get 2. So once again, this pairs up with this 2, and this negative 4 matches here. So here we got 2 as our output on the inverse, and on the main one we get negative 4. So this works. So we have just proven this true. Proven. So that should at least convince you that that will work. So this is our proof. So this is what the inverse function is right here. I'll just rewrite that so it's neater. So we got x plus 12 over 4 is our inverse function. Piece of cake. Okay, so let's give this one a shot. Now this looks a little funky, but that's okay. So our original function is here. So we're going to switch our x's and y's. So we're going to basically say that x is then equal to y minus 7 over 10. So first we multiply by 10. So we get 10x is y minus 7, doing the inverse. And then we add 7. So we get 10x plus 7 equals y. And that's supposed to be our j inverse of x. So as you get practice with solving equations, this stuff starts becoming a little bit simpler. It will still throw a lot of people, and that's normal until you get a lot of practice. So there we go. Much like this. There we are. Okay, so that's our inverse function. And now we just got to prove that that's true. So first we need to figure out what it is. Let's pick a number. Since I chose 2 over here, I'm going to keep 2. I'm just always going to say that x is equal to 2 for our check. I just pick a simple number and see if it works. I could use 0, but sometimes zeros and ones don't always work out. So you just kind of got to figure it out. But anyway, so we've got our original function here. Since I did this in red, our original function. So we're going to go look at what is j of 2. That's going to be 2 minus 7 over 10, which is kind of a nasty looking number, but let's just go with it. And that's going to be negative 5 over 10. Well, it's not so bad. So j of 2 is equal to negative 1/2, simplified. So let's keep that in mind. And so now if we take j inverse of negative 1/2, that's going to equal 10 times negative 1/2 plus 7. Well, 10 times negative 1, that gives us negative 10 over 2 plus 7, and that's going to be negative 5 plus 7. So j inverse of negative 1/2 is going to equal 2, and that's what we're supposed to get. So that has now been proven. So that's our proof. So it's been proved or proven true. So that's all we're doing. Okay, so here we've got this. And this is what we have for original function. So we want to try to find the P inverse. So this is just y is equal to 4 times this whole quantity, x plus 6, and then we cube it. And so we want to find the inverse for that. So we're going to say that we're going to reverse this and reverse these. So now we're working for the inverse function. So we switched our x's and y's, and let's just start crushing this thing. So the first thing we have to do is get rid of this thing. So now we have x over 4. So we divide this whole thing by 4. So we now have x over 4 is equal to the quantity y plus 6 cubed. We get rid of this cube by a simple process of the cubed root. So now we have cubed root of x over 4, whatever that is going to equal y plus 6. And then we simply go down and we subtract 6 from both sides. And we get, so I'm just going to put the negative 6 in front. Negative 6 and the cubed root of x over 4 equals y. And that is our inverse. If this is p of x, this is our inverse. So to prove that true, we got to come up with a number. And I'm going to take the number x can equal negative 4. I'm going to say for this, x is going to equal negative 4. I'm going to use that one to prove this. So I'm going to put negative 4 in here into both of these. And I'm going to see if we put in, so we're going to first find p of negative 4. And that's going to equal 4 times negative 4 plus 6 cubed. And that's going to, solving this, we go, that's 4. And negative 4 plus 6 is 2. So that's going to equal 4 times 2 cubed is 8. So p of negative 4 is equal 32. Now, if we put 32 into our original equation, or our inverse equation, we should get negative 4 if we did it right. So let's just give this a shot. So we have the p inverse of 32 is going to be equal to negative 6 plus the cubed root of 32 over 4. So that's still sits like this, plus the cubed root, 32 divided by 4 is 8, and negative 6 plus the cubed root of 8 is 2, and so this is equal to 4. So the p inverse, using the inverse function of 32 is 4, and that's what we're supposed to get. So this has now been proven true. So there's your proof. Right there. So that worked out for us. That was nice. Now you could put any number in there, and if you did it right, you'll get, when you put in the output into the inverse function, you get the original input for the original output anyway. Hopefully that makes sense. It's backwards math. What are you going to do? So I'm just going to make some room here. So that's the proof for that. Now we have this. So once again, switching our x's and y's. Here's x. I'm now going to write this as 15 times y minus 10 all over 32. That has to equal x. And so you simply do what we've been doing. So we go 32x is equal to 15 times y minus 10. Since we're multiplying here, we divide. So we then get 32x divided by 15 is equal to y minus 10. So then all I have to do is add 10. So we then have 32x over 15 plus 10 equals y, and that is our inverse function for t. We're doing it backwards. Here we go. So that's our inverse function for t. And now we got to prove that if we take some number and put it in here, since this is dividing by 2, really doesn't matter. I can go 10, I can go 2. I'm going to go with x is equal to, now I'm not going to take 10 because it's going to make a 0. That's going to be weird. Okay, so we got to pick a number here for x. So to check it, this is for our check work or our proof x. Let's just play a game. Let's make x 42. And if you're already looking at that, you kind of already see what I'm kind of working with here. So x is 42 for our proof. So if x is 42, we got t of x here, which is going to end up being 15. So we're going to take t of 42. So that's going to be 15 times 42 minus 10 divided by 32. So it should work out. And let's see. So that becomes 15 times 42 minus 10 is 32 divided by 32. And the 32's will cancel out. So t of 42 is going to equal 15. Now, if we put this into our inverse, so here we're going to find the inverse using the inverse function t of 15. T inverse of 15 is going to be 32 times 15 divided by 15 plus 10. And so that then becomes 30. The two 15s divide out and we get 32 plus 10. So T inverse of 15 is very simply equal to 42. And there's your proof that they do work. So don't forget the review and preview. This is a little bit quicker lesson today. It's backwards math. Give it a shot, play with some numbers, and see what you get. So until then, hope you guys take it easy, stay safe, and see you online. Please don't forget the review preview.